Well, why does voltage division happen? I don't fucking know. But, you know, the way I'm going to try and explain to you, no one else will ever explain this way. But it's kind of like I'm hitting negative that way, and I'm also hitting negative that way. Especially this one's pushing in, that one's pulling out, and that one's pulling out. I'm pulling it out in two different ways. There's something weird. And it won't appear on this line. It only appears on the line without resistance. And it requires one side to be shorted. All I can think of is it's doing a subtraction on one of the sides of it. Oh God, is that fucking impossible to understand? It is fucking tricky, man. That is fucking tricky. The other way to explain it, I don't like it, even though I didn't really explain it very well then. But the other way to explain it is that you're at some position along the wire as designated by the resistors. Like the more a resistor is equatable to a length of wire, right? And so you're some distance between negative and positive, and you sort of you lose momentum as you go. But that's actually not true. It's only when you have a junction is when it happens. Voltage division only happens at a junction. If there's no junction, it's not slowing down as it goes. It's gone full speed all the way through. But if you give it a junction, it's going to sort of slow down to where the junction hits it. I don't actually understand it, though. Current division is a lot easier. Current division is when I'm sharing so many down there and so much down there. But a current divider turns to a voltage divider if it has a load before it. And a load, and then it's not going to current divide you. It's going to actually cause the pressure to change. It causes the pressure to change, and it's quite fucking crazy. Yeah, it's quite weird how it works. And just to make it even more complicated, that there's usually a resistor here, but it's over there now. And you're going to put the device on one of the resistors. And at a capacitor short, it's going to discharge into there. And when this resistor changes, it's going to change the position of how far it is from positive and negative. And that means it's actually going to charge that capacitor different voltages. And as that resistance changes, that voltage is going to change. That's the same current. But, you know, the next thing you have to explain is why do you need the current to always be the same? And it's because of another phenomenon that makes it more versatile to try and make it like a computer without transistors. And I wonder if there's another trick I get on top of this later on from now. But why is it important to have this constant current thing? It makes it so the wires sort of end up turning each other on and off. instead of being all on at once. With transistors, you don't need it, right? But I'm pretty sure they make computers which are hybrided between shorting and with transistors together. You can make a computer with just transistors, I'm pretty sure. But you actually combine them with resistors and capacitors, and this is like more old school style. But we're going to make a really old school computer that hasn't got transistors in it. So I suppose, was that really less confusing? I don't know.